So in this video, I'm going to walk us through each of the 25 questions for Chapter 9. So these questions correspond approximately in difficulty to the questions that are in problem set number 9. And so on this slide, I've just got two links. This first tiny URL, this first link takes you to a Word document that just has the practice proofs. And so if you haven't actually had an attempt at those proofs on your own, I recommend taking a look at that document and having a go independently before you watch this video. And then this second URL just takes you to a Word document that actually has all of the proofs as well as workings out for each of them. So if you don't want to watch this entire video to see how you can complete each of these proofs, you can just take a look at this Word document instead. All right, before I actually go through the questions though, it's worth just putting on a slide super clearly the new rules we'll be practicing today. So we'll be also using those rules we've already learned in Chapter 8, but these are the new rules today: double negation, commutativity, associativity. I won't read through them all. One thing to notice is that these are rules of replacement. That means that you can move from, if you have on a piece of paper all of these rules written out, what this means is that you can go from the top line to the bottom line and the bottom line to the top line. I'll say more about that later. If that quick sketch doesn't really make sense to you, I'll say more about that later. But it's an important difference between these rules on the slide now and the rules on the right-hand side. These rules on the right-hand side of the slide are the ones we learned in Chapter 8. So these are the rules you should already know. And these are rules of implication. And they don't have that property of being able to go from the top to the bottom and the bottom to the top. Again, I'll say more about that once I do a couple of questions from this set of practice problems. But before you begin, I guess it's a good idea just to take a look at the textbook again, or take a look at your piece of paper where you've just written down super quickly what each of these rules actually amounts to. All right, so I think we're ready to go. I'm going to start with question 1, obviously. Now, I've said this before in previous videos, but when I'm doing natural deduction, I like to set up my piece of paper like this. So I move the conclusion from underneath the premises, as it is here, to the right of my piece of paper, or to the right of my premises. And this just means I'm not going to confuse my conclusion with a premise. I'm not going to end up treating my conclusion as though it's a premise, which I'm sort of liable to do potentially if it's just written underneath my premises directly. Okay, so I'm trying to show that not Q follows from these two premises. What are my premises? The first one is not P and Q, so it's a negated conjunction. And the second one is just P. I think I'm going to start this one by doing De Morgan's law. So here I'm just going to abbreviate De Morgan's with DM. So I'm going to do De Morgan's on line 1. And that gives me not P or not Q. So remember that De Morgan's enables me to change a conjunction, like what I have on line 1, to a disjunction. Okay, and this is kind of a good thing to do because look at what I have on line 2. I have P. If I have P on line 2 and I have on line 3 not P or not Q, then I can do disjunctive syllogism. One way of sort of explaining why that is to say that, well, P is the same as not P, which is what I have here, which is what I'm highlighting there. So P is a negation of the left disjunct on line 3. Or you can just think that P is sort of like the opposite of not P. P is equivalent to not P, a negation of not P. I think that's the best way to say it. So I can do disjunctive syllogism on line 2 and 3. So again, I'm going to abbreviate disjunctive syllogism with DS. So DS on lines 2 and 3 gives me not Q. And that's my conclusion. So we've done question 1. Question 2. Again, I'm going to set it up like that. Now here, I think I'm going to do De Morgan's again on line 1 again, but this time I'm going to be converting a conjunction that's not negated, although the two conjuncts are themselves negated, into a negated disjunction. So I do De Morgan's on line 1 to turn it into it's not the case that Q or R. And I've done that because look at the consequent of the conditional that I have on line 2. It's Q or R. Now on line 3, I have a negation of the consequent. So I'm in a position to do modus tollens. Modus tollens, I can do that whenever I have a conditional. And I also have somewhere else in my proof a negation of the conditional's consequent. Again, that's what I have on line 3. So I can do modus tollens on 2 and 3 to get not P. Now, here's the time where I'm just going to make a note about what rules of replacement enable me to do. So here is De Morgan's law again. Now remember, De Morgan's law comes in sort of 2 varieties. The first variety is on the left of this little text box down here. It says you can turn a negated conjunction into this disjunction that I'm highlighting here. The right-hand version says I can turn a negated disjunction, this thing here, into a conjunction, this thing here. Now, the cool thing about rules of replacement, so not just De Morgan's law, but all of the rules of replacement, which are all of these rules, right, is that you can use them, you can infer from a sentence like the one on the top, the one that I'm highlighting here, to a sentence like the one on the bottom. And you can also turn a sentence like the one on the bottom, the one that I'm highlighting here, into one like the one at the top. Okay, so they go both ways, all right? So here on line 1, I had this conjunction, which is basically the same as this thing that I'm highlighting here. And I went in the other direction, not the direction we're used to going, which is from the top to the bottom. Instead, I went from the bottom to the top. I turned this conjunction over here into a negated disjunction, which is what I have on line 3 now. And that's basically using this right-hand version of De Morgan's law, but going from the bottom to the top. And the reason I can do that is because rules of replacement are just articulating sentences that are equivalent. These sentences mean the same thing. So we can substitute one of the sentences that are equivalent for the other and the other for the one. We can go in both directions, just like in Spanish, cat is gato. So I can translate gato into cat and cat into gato. These two things are equivalent, so I can do it in both directions. So I can apply the rule in both directions. All right, so that's an important feature that it's worth just making super explicit at the beginning. Okay, well, that's what I've said on that slide. Good, they can be used in both directions. All right, let's do question 3 now. Okay, so here I've just got 2 conditionals in my premises, and I noticed that my first premise has Q as the consequent, and my second premise has Q as the antecedent. So I can just do hypothetical syllogism on lines 1 and 2. I'm going to abbreviate hypothetical syllogism with HS. So HS on lines 1 and 2 to give me not P, if P, then R. And now I see that I'm actually really close to my conclusion. So my conclusion is a disjunction, but I have this rule that enables me to convert a conditional statement into a disjunction and vice versa, right? Because it's a rule of replacement. The rule is material implication. which I'm glossing here with MI. So I'm going to do material implication on lines 3. And that enables me to convert this conditional, if P then R, to not P or R. And that's exactly what my conclusion is. So I got my conclusion in just 2 pretty straightforward steps. Okay. Question 4, 3 premises this time. Now, it's important to note that on lines 1 and 2, I don't just have conditionals, I have biconditionals. Biconditionals mean, the biconditional of A and B sort of translates as A if and only if B. So on line 2, I have B if and only if C. Now, there's actually only one rule that enables me to sort of, how do I say it? Enables me to break a biconditional sentence like this down into simpler parts. And the rule is material equivalence. So I'm going to apply material equivalence to line 1. So I'm going to turn A if and only if B into a conjunction of if A then B and if B then A. And so that's material equivalence on line 1. And so that turns what I have on line 1 into something that's like a little bit easier for me to deal with. I know how to deal with conjunctions and conditionals. And so 1 has become something that's just a little bit more manageable. I'm going to just do that again with what I have on line 2, with the biconditional on line 2. So material equivalence again on line 2 this time to turn that biconditional into something that's just a little bit easier. All right, what am I going to do now? Well, I have, what do I have? I have these conditionals, okay, and I have this A up here. My conclusion is C, which I have here and here. I think I'm just going to simplify. I'm going to simplify, oops, I did 2 steps at once. I'm going to simplify 4 first to get if A then B. And I'm also going to simplify, line 5, okay, to get this conditional out, if B, then C. Why did I simplify 4 and 5 to get those conditionals? Well, because of what I saw I have on line 3. So now I'm in a position to say, okay, well, given I have these conditionals on their own here, if A then B, if B then C, I can perform hypothetical syllogism, HS, on 6 and 7 to get this conditional, if A then C. Again, because we've got B here as the consequent, and B also shows up as the antecedent of this conditional, so I'm in a position to do a hypothetical syllogism. And this is super nice because now I have a conditional that says if A, then C. C is my conclusion. And on line 3, I have A. So I can now just do modus ponens on line 3 and 8 to give me C. And that's my conclusion. Now, I'm just going to show us an alternative way. Most of these proofs, and many in the previous video, the practice problems for chapter 8, many of them can be done in at least a couple of different ways. And so if you haven't done your problem this way, it doesn't mean that it's wrong at all. There might just be more than one correct sort of routes to the conclusion. So here's just another way you could do it, right? Instead of performing hypothetical syllogism on line 8, right, you could have just done modus ponens instead. So modus ponens on 3 and 6, all right, because on lines 3 I have A, and on line 6 I have if A then B. So I could have done modus ponens on 3 and 6 to get B, and then I could have just done modus ponens again with lines 8 and line 7, because on line 7 I have if B then C, and that would have then gotten me C, which is my conclusion. So that's just another way that I'm sure many of you would actually do this problem instead of doing hypothetical syllogism, but they're both totally correct, and I have no recommendations for doing one way or the other. They both seem to me equally simple, straightforward, and obviously correct. All right, question 5. Just one premise this time. All right, so what I think I'm gonna do, I think I'm just gonna simplify this, right? The only thing that shows up in my premises that also shows up in my conclusion is the A. So I'm gonna get that A on its own. I'm gonna simplify line 1 to get not A. And then my conclusion has a B in it, but B doesn't show up anywhere in my premises. And so that hints that I'm gonna have to use addition at some point, and I think I'm just gonna use it now, to introduce B into my workings out. So I'm gonna go from not A to not A or B via addition on line 2. All right, and now I'm actually super close to my conclusion because I have this rule, material implication, that enables me to convert a disjunction into a conditional and vice versa. So I have not A or B, and via material implication, that is equivalent to if A, then B. So I do material implication MI on line 3, and that gives me the conclusion. Now, there's something kind of interesting that we just did that's worth sort of making pretty clear. We can use addition and material implication to say that if we know that P, right, which here we didn't know that P, but we knew not A, then we can also know that if not P, then Q. So what I'm saying here is that this combination of rules, addition and material implication, enables us to go from the assertion of a simple sentence to the assertion of a negation of that. If a negation of that sentence is true, then something else, anything else, in fact, is true, okay? Which is what we've done here. We had a negation of A, and that enables us to go from, that enables us to infer that if that negation of A is false, if A is true, then B. And so this is just a combination of rules that enables us to kind of draw an inference that you might think is actually kind of strange, actually, even though it's a technically completely valid inference. So here's an example. If today is Monday is true, if that sentence is true, today is Monday, then we can conclude that necessarily it's also true that if it's not the case that today is Monday, then pigs can fly. And that's kind of weird. You might think from the fact that today's Monday is true, does it really follow that it's also true that if it's not the case that today is Monday, then pigs can fly? And in fact, it is the case that we can conclude that necessarily. This sentence that I'm highlighting, the truth of this sentence entails the truth of this sentence, okay? And we used that pattern of reasoning in this question, question number 5. And just because it's a kind of cool or quirky, strange sort of inference, even a perfectly valid, good one, but nonetheless kind of funny, I thought I'd just make that explicit, okay? That this combination of addition and material implication mean that it's perfectly valid to make an inference like this. All right. That was a comment really that was it's just for people who are already like sort of feeling good. They understand these rules. They understand how we can go from addition to material implication. If you don't fully get what I've just said there, don't stress too much about it. It was just an extra observation that some of you, it's worth pointing out, holds for some of you who are feeling good about everything so far. But if you're still sort of struggling to get the basic concepts, totally disregard this extra comment on the slide here. It's not important at all. All right. Question number 6. What are we going to do here? I think what I'm going to do is associativity on line 1. Associativity, remember, enables me to just change where the brackets are when I have a conjunction and one of the conjuncts, so in this example, this one here, the one that I'm highlighting, the right conjunct, is itself a conjunction. Okay, basically, I can change the brackets when all of the operators are and, or all of the operators are or, right? Okay, so I'm going to change where the brackets are on line 1 to turn it from P and Q and R to P and Q and R. All right, why have I done that? Well, look at what I have here. My left-hand conjunct is also what I have as the antecedent of the conditional on line 2. So what I'm going to do now is simplify line 3 just to get that conjunction on its own. And now I can do modus ponens with what I have on line 2. So I say, oh, sorry, no. Gosh, this is one of those instances where it's actually kind of super important to notice the difference between P and Q. And if you're like me, it's sometimes very, very easy to not see the difference. Okay, so I had thought, just looking at it now, I had thought that this sentence that I'm highlighting on line 4 was the same as this antecedent, but it's actually not. The antecedent on line 2 is Q and P. What I have on line 4 is P and Q. So they're almost the same, but they're not. So I need to change around the order of the conjuncts on line 4. And I have a rule for that. I have to make every single step in my natural deduction proof explicit. So I'm going to use the rule of commutativity on line 4 to change the order of the conjuncts. And now I can do modus ponens. So now I have Q and P on line 5, and I have Q and P as the antecedent of line 2. Okay, good. And so now I can do modus ponens. Modus ponens on line 2 and 5 to give me S. Question 7. All right, so what I'm thinking first, I have two premises that are both disjunctions. And the fact that the left disjunct in both premises is negated just sort of visually cues me to the fact that I could very easily do material implication on these. Okay, I can very easily do material implication on line 1, for instance, and I'm just going to do that. I turn line 1 into if A then B via MI, material implication on line 1. Then I'm going to do the same with line 2. Line 2 becomes if B then C via material implication. Okay, and now look what I have. Now I'm very close to the conclusion. I have on line 3 a conditional, the consequent of which is B. And on line 4, I have a conditional, the antecedent of which is B. And so I can just do hypothetical syllogism here. Hypothetical syllogism on 3 and 4 to give me if A then C, and that's my conclusion. All right, question 8. All right, again, I have these biconditionals on lines 1 and 2. And so I'm just going to break those down straight up into something that's easier for me to work with. So I'm going to use the rule of material equivalence. Again, it's the only rule I have to deal with biconditionals. So I'm going to do material equivalence on line 1, then again on line 2. I'm going to turn those biconditionals into conjunctions of conditional statements. All right. Then what am I going to do? Well, I have here Y or W or Y. I have W here. I have Y here. What I'm going to do is simplify 4 and simplify 5. So I'm going to go first simplification on line 4 to get this conditional, which was the left-hand conjunct of 4, on its own, if W then X. And I'm going to do the same on line 5 to get, again, the left conjunct, which is this conditional if y then z, alone on line 7. And why did I do that? Because now I'm going to do the rule of constructive dilemma on 3, 6, and 7. So 3, I have if w then y. I have I don't have if w then y. I have y or w. Then I have on 6, if w then x. On 7, if y then z. So CD, constructive dilemma, enables me to infer that it follows from those 3 lines that x or z is true. Maybe I should just write so it's super clear. Instead of CD, I'll write constructive dilemma here, so it's super, super clear. Okay, now don't forget about constructive dilemma. It came up a couple of times in the practice questions for chapter 8, but I think it's a sort of, because we don't often see it, it's a rule to forget about, okay? But it's actually super, super cool, and actually super straightforward rule. And so I'm just gonna sketch the rationale that I've given before again here. So here's an instance of constructive dilemma in action, what I've written here in the quotes. So if you can have chicken or fish, right? And you also know that if you have chicken, you'll be satisfied, but if you have the fish, you're gonna get sick. You can infer from these 3 things, okay, that this thing is also true, that you basically have a choice between being satisfied or getting sick, okay? Now, if you can follow sort of intuitively the inference that's in the quotes here and that I'm highlighting, then you have a solid grasp of constructive dilemma. You have a solid grasp of why this rule exists and why it's a valid inference. And so I put this on the slide just to make constructive dilemma, again, seem not as scary and weird as I think it is liable to seem otherwise. It's important to note too, of course, that whenever we're using the or in logic, we're using the inclusive or, and so here really when I say you can have chicken or fish, it's always an option that you can have both, okay? And so in the conclusion, when I say you have a choice between being satisfied or getting sick, it's also the case that you could be satisfied and get sick. You could have the chicken and get satisfied, and you could also have the fish and get sick, okay? That's on the cards as well. It's a possibility, but yeah, okay. That is constructive dilemma. Okay, good. Moving on. Question number 9. What do I have here? Well, what strikes me as just a possible move straight up is hypothetical syllogism, because y is the consequent of the conditional on line 1. It's also the antecedent of the conditional on line 2. So I'm just going to do hypothetical syllogism on 1 and 2 to get if x then z. All right. What else am I going to do now? Well, I'm kind of close to what I have in my conclusion, because I have this rule of material implication that I know enables me to convert a conditional statement into a disjunction and vice versa. But if I did material implication straight up on what I have on line 3, it would give me this. Oops, not X or Z, gosh, without the capitals. And that's not exactly what I want, all right? So what I'm gonna do instead, I'm going to do transposition on line 3, okay? I'm going to reverse the order of antecedent and consequent in my conditional to get if not z, then not x. Okay, now I'm going to do material implication on that. So mi on line 4, and that gives me not z or not x. Now I'm one step away from the conclusion, sorry. I just do double negation on 5 to get rid of those 2 nots. So I get Z or not X, and that's my conclusion. Now, you might know that you could, instead of doing this, okay, you might instead have just said, all right, well, on line 4, I'm gonna, oops, no, I don't want this now. On line 4, I'm gonna do straight up, I'm gonna do material implication to give me, what do I get? Not X or Z, right? Material implication on line 3. Oops. And then I'm just going to do commutativity to change the order of these. And that's another way to go. In fact, that would be an easier way, just given that it's fewer steps. Okay, so another instance where we have two perfectly valid, relatively straightforward ways of getting to the conclusion. All right, 10. What am I going to do here? I'm going to do distribution on line 1. Distribution on line 1 enables me to turn this conjunction into a disjunction, okay? So I get the A, that's my left conjunct, and I join it with B, A and B, or, and then I join A with my right, the right disjunct that's disjunct of the disjunction that's my right conjunct on line 1. It's a very wordy way of describing it. Okay, so I do distribution on line 1. I think that that's the first time we're seeing this rule so far in this practice problem set. Okay, so now I have this disjunction, and that's helpful because I think I'm going to do De Morgan's on line 2. If I do De Morgan's on line 2, DM, De Morgan's on line 2, I turn this disjunction into a negated conjunction. It's not the case that A and C. And this is really nice because here I have A and C, and here I have not A and C. And because A and C up here is in a disjunction, I can use disjunctive syllogism. So disjunctive syllogism on 3 and 4 gives me A and B. And then that's really nice because I can just simplify that to get my conclusion. So simplification on line 5 to get B. Okay, here is just me sketching out to remind everybody what the rule of distribution looks like. There are two versions of it. The version on the left here converts a conjunction into a disjunction like this. And the version, oh, I should say it converts a conjunction into a disjunction like this, and a disjunction like this into a conjunction like this, okay? Because again, rules of replacement go both ways, bottom to top, top to bottom. And then the version on the right-hand side enables me to convert a disjunction like this into a conjunction like this, and vice versa. And so these rules are super, super handy, right? Because if you have a conjunction, right, it enables you to turn it into a disjunction in order to then use disjunctive syllogism on it, which is what we did here. We had this conjunction, we turned it into a disjunction, and then eventually we used disjunctive syllogism on it. Alternatively, distribution enables us to convert a disjunction into a conjunction and then use simplification on it. So this is all just to say that distribution is super valuable because there are things we can do on conjunctions, namely simplification, that we can't use on disjunctions. And there are things we can do on disjunctions, namely disjunctive syllogisms, that we can't use on conjunctions. So the fact that we have this rule that enables us to go from disjunction to conjunction and back again sort of broadens the sorts of actions we can take, the sorts of moves we can make in a natural deduction proof. enables us to go from one thing to the other, and then that makes certain other moves possible for us. And so that's just super, super handy. And so I thought I'd make distribution super clear to everybody again, especially because it's the first time we've encountered it in this practice problem set. All right, moving on. What am I going to do first? Well, notice that my conclusion is Z, and I have Z here. On line 3, Z is a disjunct, so it's part of a disjunction. So I guess I'm sort of thinking, well, it might be nice if I can eventually use disjunctive syllogism. Maybe that's going to be what I end up doing to get Z on its own. But first, let's see what we can do. Well, I'm going to put these things together, premises on lines 1 and 2, which are two conditionals. I'm going to put them together via conjunction. And I'm doing that because I noticed that these two conditionals are actually have like this very interesting relationship. I have here, if X then Y, and I have here, if Y then X. And so I know that, well, if both of those things are true, right, I can put them together via conjunction, and from there I can just turn them into a biconditional, okay? Again, using that rule of material equivalence. All right, because material equivalence, again, I had it on the slides earlier. I think I had it on the slides earlier, or maybe it's to come. Material equivalence enables me to go from this biconditional here, if X, if and only if Y, to this conjunction here, and vice versa, okay? And I'm doing the vice versa part of it here. I'm turning this conjunction of two conditionals into this biconditional. And actually now I'm really close to my conclusion, because notice on line 3, the left-hand disjunct is a negation of X if and only if Y. So it's a negation of the biconditional I have on line 5. And so I can just do disjunctive syllogism on 3 and 5. So I'm going to do that. So DS on 3 and 5 gives me Z. So here I have if X, if and only if Y. And here I have, it's not the case that X, if and only if Y, or Z. Well, given this and this, I can do disjunctive syllogism to get Z. And that's my conclusion. All right, question 12. What am I going to do here? Well, I think I'm just going to do distribution on line 1. That just strikes me as a possible move I can make, so I may as well do it. Okay, I have this X here and here, so that means I can do distribution. So I'm going to turn this disjunction into this conjunction, and that's really nice because now I can simplify that conjunction. Simplify line 3 to get Y or Z on its own, and look at what I have on line 2, I have not Z. So again, I can do disjunctive syllogism on 2 and 4 to get Y. So here's another example. I think it was 2 problems ago, I did distribution, right? Here's an immediate example where it's super helpful. I can turn this disjunction into a conjunction as I did on line 3. And that's awesome because I can easily simplify conjunctions, which is then what I did on line 4. And that gets me almost all the way to my conclusion. Question 13. All right. Well, what am I going to do? I guess I think I'm going to do De Morgan's on this line, just because it sort of pops out at me as the thing that I can do, right? I can turn this negated conjunction into a disjunction. De Morgan's on line 1, okay, and it becomes not A or not B. I may as well just get rid of that not B, so I'm going to use the rule of double negation here, DN, double negation on line 3, just to turn this kind of more complicated looking disjunction into not A or B. All right, what next? Well, not A or B looks like something ripe to use material implication on. It's a disjunction. The left-hand disjunct is negated. So I'm going to turn it into if A then B via material implication. Okay, and now look at what I have on line 2 and what I have on line 5. On line 5 I have a conditional, the consequent of which is B. On line 2 I have a conditional, the antecedent of which is B. And so I can do hypothetical syllogism here to get, oops, oh well, that's nice, helpful to have them highlighted. I'm going to do hypothetical syllogism to get if A, then C. Hypothetical syllogism, HS on 2 and 5. And if A, then C is my conclusion. Okay. All right. What am I going to do here? Conclusion is a biconditional. All right. I'm looking at my premises and I guess I just think, well, this, premise 1, if I do transposition of that, I'll make it sort of visually easier to look at because I'll get rid of the negatives. So I'm just going to do transposition on 1 to turn it into if Y, then X. Now, what do I have on 3 and 4 and 2 and 4? Okay, let's look at 2 and 4 actually. Here I have a conditional with Y as the consequent. And on 4, I have a conditional with Y as the antecedent. And so I can do hypothetical syllogism here. So I'm going to do hypothetical syllogism on 2 and 4 to get if Z, then X. Okay, what else? Well, look at what I have now on 3 and now on 4. On 3, I have if X, then Z. On 5, I have if Z, then X. Okay, so I can put those together via conjunction, right? And then that makes it super clear to me that really I have the materials here to show that a biconditional follows, okay? So what did I do? I noticed that this was kind of the similar but in reverse to this on line 5. I put them together via conjunction. And now I'm going to do material equivalence on that. I'm going to turn what I have on line 6 into this biconditional, X if and only if Z, and that is exactly what my conclusion is. Now, here's sort of like a tip, right? When we have a conclusion that's a biconditional, this is what I mentally think. I think, okay, well, this conclusion here, this biconditional, I could do material equivalence on it, right? And if I did, I would have this sentence or I would have this sentence. So basically what I think is, okay, what I have as my conclusion is equivalent to this thing that I'm going to highlight in green, and it's also equivalent to this. Okay, so I just sort of note that mentally. I think, okay, if I can get what I have in green, or if I can get what here is in blue, then I'll be one step away from showing that my conditional is true. And so I think, okay, well, if I can show that these two conditionals hold, if P then Q, and if Q then P, if I can show that those two conditionals independently are true, then I can put them together via conjunction and then do material equivalence on it and get my conclusion, which is exactly what I did in this question. Alternatively, I can think to myself, well, if I can show that P and Q is true, either because I show that P is true and I show that Q is true and then I put them together via conjunction, or just because I get P and Q together somehow, then I can just add this thing that I'm going to now highlight in pink. I can just use addition to add that whole thing in pink, and then I'll be one step away from the conclusion because I can apply material equivalence to that. So here on the right of the slide, I'm just sort of sketching what I think mentally when I approach a natural deduction problem, the conclusion of which is a biconditional. I think to myself, like, these are two potential roadmaps to getting the conclusion. I should be on the lookout for these two different sets of possibilities two different routes to the conclusion. Okay. Question 15. I think here, look at what I have on line 1. Now, we haven't seen an example of this rule yet, exportation. So take a look at your notes to remember it again. This looks like something I can do exportation of it, on. I have a conditional. The antecedent is a conjunction. So I can do exportation on it and turn it into this. Okay, the rule of exportation, EXP here, enables me to convert a conditional like this, a conditional with the antecedent as a conjunction, into a conditional, the consequent of which is itself a conditional. That's what the rule of exportation says. Okay, why is this good? Well, look at what I have on line 2. I have A. So now I can do modus ponens on 2 and 3 to show that if B then C is necessarily true. And that's super handy because now I'm really, really close to my conclusion. I can just do material implication on line 4 to turn it into not B or C. Question 16. Okay, this looks like another instance where I can do distribution. I have a conjunction. The two conjuncts are disjunctions. And I have a Y here that I've highlighted and a Y over here. So I'm going to turn this conjunction into this disjunction via the rule of distribution. Okay, why is that good? Well, look at what I have on line 2. I have not Y. So having done distribution on line 1, I can now do disjunctive syllogism. Disjunctive syllogism on line 2 and 3 to get X and Z. And then that's awesome because I can just simplify that to get Z, and that's my conclusion. 17. Okay. Notice that here I have Z, here I have Z. So I'm sort of thinking, well, if I could turn this into a conditional, the consequent of which wasn't this conditional, but was just Z, then I could do modus tollens. So what I'm going to do is do exportation on line 1. I'm going to turn that conditional, the consequent of which is itself a conditional, into this conditional. Okay, that's the rule of exportation. We're just using it in sort of the other direction from the direction we used in the previous question. Okay, and that's really nice because now I can do modus tollens. I have not Z there, and I have a conditional, the consequent of which is just Z. So I can use modus tollens on lines 2 and 3 to show that not X and Y is true. And now I'm really close to the conclusion because if I just do De Morgan's on this, if I go De Morgan's on line 4, the negated conjunction becomes not X or not Y. 18. All right. The thing, I can't yet see myself directly, see a route, directly to the conclusion. But I can, what just sort of strikes me as the first possible move I can make is De Morgan's on line 1. I have a negated conjunction that's ripe for De Morgan's. So I'm going to turn it into not P or not Q. I may as well just do double negation on that, line 4, to turn that not Q into just Q. Okay, what can I do now? Well, I guess this looks to me like something I can just do material implication on. So I'm going to do that. I'm going to turn not P or Q into if P then Q via material implication. And it's worth saying that I just did that because, again, it just struck me as something possible I could do. And at this point, I can't see how I'm going to arrive at my conclusion directly. So I'm just sort of doing things that strike me as legal moves. And I'm going to do the same on line 2. Again, this disjunction just looks very apt for material implication. So I'm going to do material implication on line 2 to get if Q then R. Okay, well now look at what I have. I have these two conditionals on 6 and 7. The consequent here is Q. The antecedent here is Q. So that's cool. I can do hypothetical syllogism on that. Turn it into P, if P then R. Hypothetical syllogism on 6 and 7. And now I can see my way to my conclusion. Because look at what I have on line 3. This is why it really pays to constantly sort of scan up and down your proof to make sure you're constantly sort of reminding yourself of what all of the premises are, what all of the sentences you have on your piece of paper are. So once I make sure I notice what I have on line 3, I can see that I can do hypothetical syllogism with it again, because I have S here, I have R here, and I have R here. So I can do hypothetical syllogism on 3 and 8, hypothetical syllogism 3 and 8 to get if P then S. 19, we are almost done. 6 more questions to go. All right, again, number 1 is apt for distribution, so let's do it. Turn the conjunction into distribution. I can do it because I have P here and I have P here. Okay, and that's good because now I can do disjunctive syllogism. Look at what I have on line 2, I have not P. So I'm going to do that disjunctive syllogism on lines 2 and 4 to get Q and R. What next? Well, look at what I have on line 3. I have if Q, then if R, then S. So I have a conditional, the consequent of which is itself a conditional. So I can do exportation on that. So let's do exportation on 3 to turn it into Q and R, if Q and R, then S. And now look at what I have on 5 and 6. I can do modus ponens on that. Modus ponens 5 and 6 to get me S. Now let's just show an alternative way of doing this one. Okay, so I could have just wait, no, we don't want to cross this one out. At this point, I could have just said, okay, Q via simplification on line 5. Okay. Oh, actually, this wouldn't work. So I was going to say we could have gone 6 to get simplification on line to get Q via simplification on line 5, then on line 7 we could have used this Q with what we have on line 3 to get if R then S. Modus ponens 6 and what is it? 6 and 3. But actually this wouldn't get me the whole way to my conclusion. No, that wouldn't get me there. Because once I get here, I have this conditional, if R then S. Oh no, it would get me. Because look what I can do here. I can do simplification on line 5 again. Okay, so this alternative isn't going to be any quicker, but it's still going to work. Okay, so I can do this. I can do simplification on line 5 again to get R. Simplification on line 5. Okay, now I can do on line 9. Now I can do modus ponens, again modus ponens 7 and 8 to get S. Okay, so that's an alternative way. It's only one step longer, so that's it's pretty much as good. One step, an alternative way that doesn't require using exportation. So I hope people are sort of now realizing that the more rules you know, the more kind of alternative routes to the conclusion become possible. And so like the more room for creativity there is in natural deduction proofs. All right. I think what I'm going to do, here I have A, here I have it's not the case that A or B. My conclusion involves C's and D's, and here I have C's or D's. So I kind of want to get this thing that I'm highlighting now, this conditional, on its own. That would be nice. So what I'm going to do is do addition to line 1. I'm going to turn A into A or B. Or I'm going to say, from the fact that A is true, A or B is also true. And now I have something on line 3 that enables me to do disjunctive syllogism with line 2. So I'm going to go disjunctive syllogism 2 and 3 to get if C then D. Why? Because as I say here, yep, A or B is equivalent to, is exactly the same thing as it's not the case that not A or B, okay? Those two things are equivalent. So I have a negation on line 3 of this negated disjunction here, the one that I'm highlighting. Okay, so now I have if C then D. That's super close to my conclusion. I can just do transposition on it to get if not D, then not C. So it's just super important to have a kind of cheat sheet, I guess, of rules with you the entire time when you're doing these, just so you remember what all the rules are and possible moves kind of strike you when you're doing the proof. Okay. All right, notice what I have here on lines 1 and 2. These things strike me as kind of having this very similar sort of relationship. If I do material implication on 2, I turn this disjunction into this conditional. And so now what I have on line 4 is a negation of a conditional, the same conditional that appears in line 1 as my left-hand disjunct. And so now I can do disjunctive syllogism. So I'm going to do disjunctive syllogism on 1 and 4 for negated conditional 1, a disjunction with one of the disjuncts being that conditional. So I can conclude via disjunctive syllogism that the other disjunct here, which is itself a conditional, is true. Okay, and now look at what I have on line 3. I have not C. So with 3 and 5, I can do modus tollens, MT, 3 and 5, to get not B. And that's my conclusion. Okay. What am I going to do here? Well, I have these premises, 1 and 2, that are conditionals. There are negatives everywhere, so I'm going to do transposition twice. Transposition on 1 and transposition on 2 to get rid of those negatives. That just makes it sort of easier on the eye. All right, now look at what I have. I have this Y here and this Y there, so I can do hypothetical syllogism on 4 and 5. Hypothetical syllogism, oops, this should say 4 and 5 to get if X, then Z. Now look at what I have on line 3. I have X, so I can just do modus ponens with 3 and 6. 3 and 6, modus ponens, Z. That one's nice and easy. Okay. So I have this conjunction of not A and not C. So maybe one way I'm going to get to this conclusion is to get not A on its own and not C on its own and put them together via conjunction. I don't know, but that's one possible sort of map to my conclusion that I should be on the lookout for. Let's just simplify line 1. Let's just do it twice because it's going to sort of break it up, make it a little bit more manageable. Now I have 2 negated conjunctions on line 3 and on line 4. I'm going to do De Morgan's on line 3, turn that negated conjunction into a disjunction. Let's just do that again, do the same thing on line 4, turn the negated conjunction into a disjunction. Okay, and this is nice because look at what I have on line 2. I have B. Here I have not B or not C. Remember, B is exactly the same as not B. So I have on line 2 a negation of the left disjunct on line 6. So I can do disjunctive syllogism. Oh, sorry. Here I was thinking I was going to do disjunctive syllogism with 2 and 6, but actually I'm going to do it with 2 and 5 because I also have a not B here. So I'm going to do disjunctive syllogism on 2 and 5 to get not A first. And that's nice because that's half of my conclusion. And now let's do the other one that I was saying. I have B and then I have not B here. So I can do disjunctive syllogism to get, not C. Nice. Now I have sort of the raw materials for my conclusion. Not A and not C. Conjunction on 6, 7, and 8 to get my conclusion. All right, second last question. I have these 2 premises, a conjunction and a disjunction. Let's simplify line 1 first. All right, I have this disjunction. Let's do De Morgan's on that to make it a negated conjunction. De Morgan's on line 4. Now look at what I have on line 2. I have P and Q as one of the disjuncts. On line 4, I have a negation of P and Q. Yep, there we go. So I can do disjunctive syllogism on it to get S and R. Disjunctive syllogism 2 and 5 gives me S and R. And lo and behold, my conclusion is just S. So I can do simplification on line 5. Simplification on 5 to get S. That was nice and easy. Last question. Again, I have a conclusion that's a biconditional, so I'm going to do that thing, or think that thing that I said before. I'm going to note to myself, okay, a biconditional is equivalent to this conjunction of 2 conditionals. It's also equivalent to this disjunction, okay? How do I know that? Because I know the rule of material equivalence. And so once I note that, I think to myself, okay, one way I could get to the conclusion would be to show that this conditional is true, and then to show that this conditional is true, and then put those 2 conditionals via conjunction, and then do material equivalence. Another way I might end up arriving at my conclusion would be to show that P and Q is true, and then I'd just do addition to that. I'd add all of this stuff that I'm highlighting now and do material equivalence to it. Or I might show that this conjunction of not P and not Q is true, and then I do addition on it to add this, and then do material equivalence again. So what have I said? Those are 3 different kind of possible routes to my conclusion. And so I just, when I see the conclusion is a biconditional, I just sort of take note of that. And that means I'm just on the lookout for different possibilities for completing the proof. So what am I going to do here? Because my premises are themselves biconditionals, I'm just going to do material equivalence on them to break them down into something that's more manageable. So material equivalence on 1 gives me this conjunction. Material equivalence on 2 gives me this one. All right. I'm interested in x's and z's. So what I think I'm going to do is simplify line 3 to get if x then y. And then I'm going to simplify line 4 to get if y then z. So what did I do? I simplified to get this conditional first. I did that on line 5. And then I simplified to get this one. Whoops, this one, if y then z. Why did I do that? Because I'm ultimately interested in x's and z's. And if I get these two conditionals on their own, the one that I have on line 5 and the one that I have on line 6, I'll have the kind of raw materials to do hypothetical syllogism, because look, here I have a y as the consequent, here I have a y as the antecedent, and so I can do hypothetical syllogism here, hypothetical syllogism HS on 5 and 6 to get if x then z. And that's one of those conditionals that when I was thinking about my potential roadmap, whoops, here, I was thinking I could get, okay? So if I can get the other one, what slide was I on? If I can get a conditional going in the other direction, if I could get if z then x, then I'm super close to being finished. So how am I going to do that? Well, I'm going to go back to these 3 and 4, okay? And I'm going to simplify and get the other things isolated, all right? So I'm going to simplify 3 to get if y then x. Where is that one? If y then x, that's here. I'm going to simplify it again to get if z then y. And why did I do that? Because now I have the kind of inverse of what I had before. I have a y there as the antecedent, a y there as the consequent. So let's do hypothetical syllogism again. And this one's going to give me if z then x. Hypothetical syllogism on 8 or 9. And that is exactly what I want, right? Up here, where is it? I have if x then z. Here I have if z then x. Let's put those together via conjunction. And now I'm just one step away from my conclusion. I have this conjunction of two conditionals that enables me to say, okay, via material equivalence on line 11, I get the biconditional. Nice. Okay, so this one's like, in some ways it's quite straightforward, but it takes a little bit of kind of fiddling with the basic building blocks you have at 3 and 4 to arrive at the conclusion. And it might help to just sort of do material equivalence on lines 1 and 2 to get these two conjunctions here. And then if you want, you could just simplify, do simplification on 3 and 4. So do simplification 4 times in a row, right? To get these conditionals on their own. And then you just can sort of look at those 4 different conditionals you'd have and play with them mentally, play with them on the paper until you arrive at, via hypothetical syllogism 2 times, what we have on line 7 here and what we have on line 10. So it sort of might take some fiddling, but what it really amounts to is breaking these premises, these 2 conditionals down into their most simple parts and then seeing what you can do with those parts. Okay, cool. And so that's the end of 25, and so we've gone through all of the practice problems for chapter 9.